In this video, we are going to dive deeper into Pandas, one of the most powerful and widely used Python libraries for data manipulation and analysis. We begin by importing the necessary libraries, Pandas and NumPy. Pandas is imported as PD and NumPy as NP, following common Python conventions. I have already added the data for our dummy data frame, which we also used in the last lecture. We have a matrix of random numbers drawn from a normal distribution using NumPy, coming in 5 rows and 4 columns. There's also a list for named indices that we will use instead of numerical indices, along with some header names for the columns. But we still need to put the data together to get a data frame from it. I set up a variable called df, which will hold our data frame, and then call the data frame function from Pandas, providing the random array as the data. For the index parameter, I feed in the index list. And for the columns, I pass the columns list. As you can see, a data frame is essentially a table with rows and columns similar to a spreadsheet. In the last lecture, we talked a lot about selections, or more precisely, about indexing and slicing. I want to extend on that topic of selections and talk about conditional selections. A conditional selection is about filtering data based on a condition, applied just like in NumPy using operators such as greater than or equal to, less than or equal to, unequal, or exactly equal to. We simply take our data frame and put a condition behind it. For example, let's say we want to see which elements are greater than 0. This returns a data frame of the same shape, but with Boolean values. True for values that meet the condition and false for those that don't. We can use this Boolean result to filter the original data frame, keeping only the values greater than 0. The other values will be replaced with NaN, so not a number, indicating that those entries didn't meet the condition. With Pandas, we can also check a condition for only a specific column, and then only keep the rows where the condition is met. For instance, we can filter the data frame to keep only the rows where the values in column W are greater than 0. This gives us a subset of the original data, keeping only the rows where the condition is met. We can also count how many times a condition was met by taking the sum of the condition. So if I take the sum and then apply the condition that column W should be greater than 0, I get the number of rows where the condition is met. If we have more than one condition that needs to be met, we can also combine several conditions. For that, we use the AND operator for logical AND and the pipe operator for logical OR. I will start by writing the conditions into variables to keep it simple. For condition 1, we might want to filter the data frame where the values in column X are less than 0. The second condition could be that the values in column Z are greater than 0. Now I set up the data frame with square brackets, provide our first condition in round brackets, and then either use the AND or the pipe operator depending on whether I want both conditions to be met at the same time or just one of them. I will start with the pipe operator for logical OR. After that, I set up round brackets again and provide our second condition. Those are the rows where at least one of our condition is met. If I change the operator to AND, fewer rows remain because both conditions need to be met at the same time. Let's now move away from selections and deal with some other important topics that Pandas offers. Pandas provides several methods to quickly get information about the structure and content of a data frame. For example, the df.info method gives an overview of the data frame, including the index, the columns, and the data types of each column. Even though the data types are already listed here, we can also use df.dtypes to get this information if we do not care about the other information. The df.describe method is another valuable tool as it provides summary statistics for each numerical column, including the count, mean, standard deviation, minimum and maximum values, and percentiles. This gives a quick overview of the data distribution, which we will use quite a lot throughout the course. We can also access various parts of the data frame, such as the column names and row indices. Using df.columns, we get a list of the column names. And df.index gives us a list of the indices. This can be useful when we want to loop through or manipulate specific parts of the data frame. Let's exchange our dummy data frame for more realistic data. This dictionary holds two keys, one with strings of land use types and the other with corresponding areas in square kilometers. For example, this urban area has 1.3 square kilometers, this pasture half a square kilometer, and there is another urban area with 2 square kilometers. Let's turn this dictionary into a data frame. I override my df variable, set up a data frame, and pass the dictionary. Pandas will figure out how to set this up by itself. As you can see, we have land use classes that show up several times, as this might represent different regions in your land cover classification. If you want to combine the areas by their respective land use classes, we can use the group by method, which is another powerful feature in Pandas. Using the group by function, we can group the data by a specific column and then apply aggregate functions like sum, mean, or count to each group. This is extremely useful for analyzing and summarizing data by categories or groups. So I get our new data frame, say .groupBy, and tell Pandas which column should be used to group the data, which is the land use column in our case. If I run the cell now, I just receive back an object, which doesn't tell me much about the data. But as soon as I apply an aggregate function, like taking the sum of each group, I get back a data frame showing the sum of each land use class. I could also take the mean, the minimum, or perform many other operations. If I want to have a statistical overview of the data, I can also use the describe method. Now let's move on and see how we can apply a function to a data frame. I have already prepared another data frame that contains cities with their corresponding populations and areas in square meters. Having the area of a city in square meters is not very convenient, so we should convert them into square kilometers. Let's set up a function that can do that. We define a function called sqm to sqkm, and the only parameter will be the value, which will hold the area in square meters from the data frame. As the calculation is simple, we can directly return the value divided by 1,000,000. Now we need to apply this function to our data frame and store the result in a new column, which I can set up by getting our df_pop variable and providing the name of the new column in brackets. Then we need to tell Pandas what we want to write into it. The data will be based on the column with the area in square meters. And upon those values, we apply our function. And that's how we apply a function to a data frame. Sorting data is straightforward in Pandas. Using the sort values function, we can sort the data frame based on the values in a specific column. For example, we could sort the data frame by the values in the population column, in ascending or descending order, depending on whether we set the ascending parameter to true or false. This is helpful when you want to see the data in a particular order. The next and final part of this lecture will probably be the most important one for this course, as it deals with opening large CSV or Excel files, which will provide the input data for our AI models. Pandas can read data from a variety of formats, including CSV files, Excel spreadsheets, JSON files, and more. Similarly, it allows you to export your data frame into different formats, making it easy to save your analysis or share it with others. There is a CSV file with air quality measurements regarding nitrogen dioxide concentrations from several measurement stations in Wuppertal, Germany. Let's see how we can open this CSV file. Looking at this chart, we see that we can open a CSV file with read CSV. So we take Pandas and say read CSV and provide the folder path to the CSV file within brackets as a string. We have two options to provide the path, either as an absolute path, which includes the hard drive and all the folders that lead to the CSV file, or a relative path, which starts relative to this notebook. To tell Python that we want to provide a relative path, I write /. There is a subfolder called data right next to this notebook file, so I provide that subfolder name, and within that folder, I can find the CSV file which I specify along with its file extension. After executing the cell, I do not get any errors, so Python found the file I wanted to open. However, it doesn't look right. Taking a closer look and reminding myself that CSV stands for comma-separated values, I notice that this file uses semicolons instead to separate the values. This is why it doesn't look correct. So this time, I tell Pandas that the separator is a semicolon. And now the spreadsheet looks as it should. By default, Pandas shows us the first and the last 5 rows, indicating that this is data from 2008 up to 2022, containing 4,406 measurements. Now I would like to extract only those measurements that were done by measurement point 7. So I set up a new variable that contains a selection of our large data frame. And the condition of the selection should be that the data frame's column measurement point is equal to 7. This results in only 175 rows of data. To store the result in a CSV file again, I take a look at the chart and see that I can write a CSV file with 2 CSV. So I get my new data frame and say 2 CSV. And then provide the folder path, which should be almost the same as the path of the original file. But I add station 7 to it. We can keep the semicolon as a separator to stay consistent, but remove the numerical index that Pandas added to the data frame. Again, the fact that the folder path is the first thing to mention and that I can specify the separator or remove the index are all things you can find in the documentation. I also have to look these things up when using new functions. In this video, we've covered several key aspects of working with Pandas, including creating data frames, applying conditional selections, filtering data, and using powerful features like grouping or sorting. We also explored methods for getting information about the structure and content of the data frame. Understanding these core functionalities will help you efficiently analyze and manipulate datasets in the upcoming projects.